Good afternoon, everyone. Thank you for giving me the opportunity to participate in this event. Okay. Yeah. Let me introduce myself. I'm a researcher at the University of Burgos, and I'm part of a building engineering research group. This is a multidisciplinary group comprised of industrial engineers, architects, and chemists. We have over 14 years experience researching the reuse of different types of waste and its recovery in the design of sustainable construction material. We were aware of the necessity to make our products attractive to manufacturers. And this is very difficult because in materials based on gypsum or cement mortar, the raw materials are very cheap with suitable performances. To give you an idea, our research group has 20 patents and only 2 are currently being used. When we were thinking about the idea of the life-repolyuse project, we knew of the importance to collaborate with a manufacturer in order to achieve a circular economy experience in the market. This is the reason because it is important to look for companies that have an environmentally friendly approach. And we have implemented this strategy in the life-repolyuse project, which addresses the problem of waste management through the use of innovative techniques of reduction and reuse, integrating them into a new gypsum ceiling tile. The project began in September 2017 and finished in December 2020. It has been coordinated by the University of Burgos in partnership with Texa, which is a Spanish construction company, and Forma, a Spanish manufacturer of gypsum ceiling tiles. life-repolyuse was a project carried out in order to develop a commercially viable product and expresses the idea of circular economy. This picture shows the phases from the initial waste generation to the end of its life. First, waste is generated in a factory of panels, and then it's used in the production of new ceiling tiles, which are then used in a building. If this building is demolished at the end of its life, waste can be recovered and the process can start again. The new building material is a removable ceiling tile from waste, as you can see from the picture. The objectives of this project were to maximize the reuse of waste. In order to reduce the carbon footprint, it was necessary to do the following. First, to reduce the environmental impact associated with incineration techniques, reduce the extraction of natural resources, as the implementation of the new technology can substitute gypsum by waste, reduce the consumption of energy and water compared to the current manufacturing processes. Another one of the objectives is to transfer and replicate life-repolyuse technology to other EU countries. And finally, the last one is to include civil society and local actors in order to promote sustainability in the construction sector. Moving on to the project's work plan. It begins with the recovery of waste from the generating industry, which is PAP. The waste is transported to the Forma manufacturing plant in order to manufacture new ceiling tiles using the technology developed by the University of Burgos. This new material has been used in 3 different demo sites in Coventry, in UK, and Spain, where we have been monitoring the energy efficiency, humidity and temperature parameters in order to analyze the comfort of the interior spaces of the buildings. A key phase of the project has been the design of mixture substituting different amounts of gypsum with pure waste and optimizing and testing the mixture in order to discover their technical qualities. All tests were carried out at the university laboratory and at the manufacturing plant so that the laboratory and manufacturer work jointly. Okay. And now I'm going to talk about the waste protocol that has been followed in life-repolyuse from PU generating company in Cuenca, Spain, to Yesiforma, which is the manufacturer in Zaragoza, Spain. PAP produces panel sandwiches composed of metal and pure foam, followed by another layer of metal. During the panel sandwich production process, damaged panels are discarded, which means the metal needs to be separated from the pure foam. As a result of this process, we can obtain pure leftovers. This same material is also obtained from product testing. Okay. On the other hand, when panels are sanded, powder is produced. This material is pressed and made into pellets. The pure waste is then stored and taken to landfill sites. The new technology developed during the life-repolyuse project makes it possible to divert some of the pure waste from landfill and transport it directly to the Yesiforma manufacturing plant, where it can be used as a raw material to make cement tiles. Okay, it's necessary to ensure this in all phases of the polyurethane waste management process. Traceability is important to instill confidence in products and processes, as well as to mitigate any possible negative environmental impact. We've created a traceability sheet in order to identify the waste from the origin to its final destination. Okay, in this picture, you can see the manufacturing process at Yesiforma plant. On its arrival at the manufacturing plant, the waste is placed into an industrial shredder. The powder obtained is mixed with gypsum and other components in order to produce the new product. Because the new product is environmentally friendly due to being 32% lighter, the thermal conductivity level being almost 26.7% lower, and the reaction to fire classification being A1 according to Eurocode, our cement tile was given the CE mark. Okay, and now on to legislation. In order to use recovered pure waste in the manufacture of new construction materials, it's necessary to analyze current EU legislation regarding the use of waste as a raw material due to the fact that there are some barriers. As I have explained before, PU that is used as a raw material can be in the form of leftovers, which is completely clean, or waste in which the PU is mixed with other components. There are specific regulations for each type of PU. According to legislation in certain countries within the EU, such as Spain, Italy, or Portugal, clean PU waste is allowed to be freely reused in the manufacture of new construction materials. However, if the manufacturer wants to use in PU waste the regulation that must be followed is the EU directive on waste, which makes it compulsory for the manufacturer to be registered as a waste manager. Okay, During the project, a life cycle assessment of the standard ceiling tile and the new tile was carried out, and the results of the assessment were compared. The process was not carried out from cradle to cradle due to the fact that the manufacturer has not recovered the PU at the moment, no? And the gypsum waste yet. The regulation followed was the European Environmental Management regarding life cycle assessment. And the assessment was carried out at the Gesiforma manufacturing plant from 2018 to 2020. We used 1 square meter as the functional unit in the system. Okay, and the product system is comprised of the following processes: raw material extraction, raw material transportation to the manufacturer, ceiling tile manufacture, transportation of the finished tile for installation, period of use in a building, and finally, the tile disposal. The environmental impact of this new material is that we can save the use of raw materials such as water and gypsum. Using this tile means that the temperature difference is improved between the outside and the inside of the building. And during the manufacturing process of the new ceiling tile, there is a 14% CO2 reduction and lower energy consumption. So due to the positive results of the LCA and the beneficial technical specifications, the new product has obtained the eco-label. And now regarding the product's launch, a contract has been made with Gesiforma to grant it exclusivity of production. Gesiforma has included the new ceiling tiles in its distribution network and marketing campaigns. It seems as through some of these marketing strategies have been successful because some potential clients have shown interest in buying the product. Please have a look at this slide, which shows the eco-label, the packaging, and the link where you can find the complete documents. Okay, and now to conclude, the process of PU waste recovery from the generating industry to its use at the manufacturing plant has been explained. The beneficial properties of the new construction materials have been outlined, such as its lightness, its low thermal conductivity, and its fire reaction classification. As part of the life-repolyuse framework, a new storage and shipment protocol has been developed to guarantee the traceability of the PU waste from its origin to its destination. On analyzing the legislation on the use of waste as a raw material in the manufacture of construction material, we've discovered that there are no legislative barriers to the use of clean leftover PU waste in the case of Spain, Italy, or Portugal, as there are specific laws which permits this waste to be freely used. Although the idea of using waste seems advantageous both to generating industries and manufacturers of new construction materials, it's still necessary for it to be easier to do so under the legislation of various administrations. This is mainly due to the fact that in the case of waste, there still are currently some prohibitions. And finally, we think that the project has been successful because the fact that we found a manufacturer willing to manufacture the product during the first part of the process. Gesiforma, in this case, is the leading company in the gypsum ceiling tiles manufacturing sector in Europe. And this company has environmentally friendly policies, therefore they wanted to participate in the project. And we think that this is an example, life-repolyuse as an example of a circular economy. So that's the end of this presentation. So thank you very much. I hope you found it interesting.